binary tree structure in array. All right. Let's try to build a binary tree structure in array. Yeah. So that's our goal. Yeah. The question, how to build it. Yeah. So we need to do some analysis. So we try to get some understanding before we can do it. Yeah. All right. So here, let's look at a special data structure called a heap data structure. Yeah. So why we need this special heap data structure? There are some special properties for the heap. The first one, use an array as the underlying storage object. So we have a binary tree, but we store the binary tree in some underlying array. Yeah. So that's the first property. Okay? Yeah. Use a simple way to store a binary tree. If it is possible, that looks pretty good. Yeah. Second, near complete binary tree. It's hard to require the whole binary tree is a complete. You cannot, because in that way you require the number of nodes must be 2 to the k minus 1. If your n equals that number, then you can get a complete binary tree, right? The number of nodes. Yeah. All right. So, but for the general n, not necessary. So not in this form, then we just get a near complete binary tree. What do we mean near? Yeah, here. So let me show you that structure. You try to fill all the levels except the bottom level. Bottom level is not filled. Okay? If you can fill the remaining part of the bottom level, you would get a complete binary tree. But in general, you do not. Okay? Here you can see for this, so this is called near complete binary tree. So you can see this, in this example, it is not a full binary tree, right? Because this node, this one, actually this one, only one child node. Not that 0 or 2 way we need. Yeah. So it's not a full binary tree, but near complete binary tree. Okay, yeah, that's the probably number 2. Number 3, sufficient space for dynamic data. So this part we need to, do some extra work. Yeah. What do you mean sufficient space, right? Because the current space eventually run out. Eventually, you will use up all the existing space. So at a certain point, you need to add a new space to store the data. So that part we need to fix sometime later. Okay, yeah. Question, property number 4. Certain relationship among nodes. Yeah. Because in a binary tree, you have parent-child relationship. You need to maintain parent-child relationship. Left child, right child. Okay? How do you maintain that relationship? In the original array, we do not need to do that. But in the special array, underlying array for the heap data structure, we need to do that. Yeah. So here you can see you need to do quite some work before we can use this data structure efficiently. Yeah. All right. Here, regarding this question, how much space is sufficient? How to know? Yeah. So later, we need to do something. Okay, yeah, so this is still, it's an open question right now. So later, we try to do something to solve this problem. Okay, space problem. Yeah. All right. Next, how to make array space sufficient for dynamic data. Yeah. Here, let's just to give you some idea. What do we need? What do we want for this part? Yeah. All right. First, it is unknown about the amount of incoming data. Nobody knows that. Data keeps coming in. In future, how much space do you need? Nobody can predict that. Okay? Yeah. Yeah. So the idea, so we try to solve this problem. Yeah. Assign certain amount of space to an array initially. Initially, we do not have much data. We just assign appropriate amount of space to array. Then we allow this array to grow to get more and more data. So that idea. Yeah. Second, keep adding data and monitoring the size closely. Yeah. Because eventually our data will use up all the space in the given array. So we need to monitor the size closely. Okay? Yeah. Number 3, when a threshold is reached, a new array with larger size is created. Because warning, yeah, we set some warning line, threshold, warning line. When that warning line is reached, still before the overflow, okay? If it's overflow, that's too late, okay? So we don't want to do action when we get overflow. That's a runtime error. We don't like it. Yeah. So we set some warning line with certain room before the overflow. Then we do some action when we hit that warning threshold line. Yeah, that's the meaning. Yeah. So what kind of action we should do? We create a new array with larger size. So we can hold more data items, and we copy the old data items to this new larger array. Then, continue the, data processing task. Okay, yeah. All right, but when we do that, so that's a simple idea, right? But when we do that, there is some problem we need to fix. So what's that? Usually, it is very expensive to copy a large data. Data copy could be very expensive. Okay, yeah. So if I draw a diagram, it's like this. Yeah. So if you do not copy that big data, so your response time is pretty reasonable. Then you hit this bottleneck. When you need to do copy, you need to spend a lot of, you need to hold all other activities, then make this copy, So this bottleneck, very slow. So the users, they need to wait relatively long time in this period. That is a very bad experience. You want to avoid that. Okay? Actually, you really want to spread that amount of work relatively evenly in certain period of time. Okay? Spread that copy work in some wide period of time, then you can eliminate that bottleneck. Eliminate that bottleneck. Okay? Yeah. That's our goal. So then the users, they do not need to wait a long time. So they always get a reasonable amount of response time. How good is that? Okay? So that's a good solution. Yeah. The idea. Yeah. So later, if we have chance, so we try to do something for this idea. Okay. All right. So let me start our B.3, our second video for the heap sort. Yeah. Right here. Yeah.